This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Welcome to the Carnival of Chance. Today, we are going to learn how to write the probability distribution for a game of chance. Our first stop at the carnival is the raffle drawing. There were 200 tickets sold, and only one will be the winner. The winning ticket will get a $1,000 prize. To illustrate our chances of winning or losing, we can create a table called a probability distribution. In the first column, we list out all the possible outcomes, also called the payoff. Typically, we label this as a capital letter such as x, which is called a random variable. A random variable is a function that assigns a numerical value to each outcome in a sample space. So in this case, what are the possible outcomes? We will either win the $1,000 prize, or we will lose, meaning we'll win $0. Great! Now let's find the probability of each outcome occurring, which we will put in the second column. Since 200 tickets were sold, there is a 1 in 200 chance of having the winning ticket, so the probability of winning $1,000 is 1 over 200, or 0.005. Now, what is the probability of winning nothing? That would be the remaining 199 tickets over 200 total tickets, or 0.995. We could have also found this by subtracting 0.005 from 1, since the probabilities of all of the events in a probability distribution need to sum to 1. Cool! We've just created a probability distribution. The chances of winning this raffle are pretty low. Let's take a look at another game at the carnival and see if it has better odds. Our next stop at the carnival is a game where you spin a wheel to win a prize. On the wheel are the numbers 1 through 30. If you land on an even number, you win nothing. But if you land on an odd number, you win $30. Let's create a probability distribution to illustrate this. In the first column, we will list all the possible outcomes. For this game, we will either win $30 or win nothing, which means $0. Now let's find the probability of each outcome, which we will list in the second column. From 1 through 30, half of the numbers are odd and half of the numbers are even. That means the probability of winning $30 is 15 over 30, or 0.5. And the probability of winning $0 is also 0.5. There is a 50-50 chance of landing on even or odd, so our chance of winning is the same as our chance of losing. Let's try one more game at the carnival. For this final game, you'll draw a card out of a giant hat to determine your prize. Out of 500 total cards, there is one card that earns you $240, 4 cards that earn you $125, and 17 cards that earn you $47. The rest of the cards win you nothing. Let's create a probability distribution. First, we'll list all of the possible outcomes: winning $240, $125, $47, or $0. What is the probability of winning $240? Out of all 500 cards, only one earns you this prize, so the probability is 1 over 500, which is 0.002. How about the probability of winning $125? Out of all 500 cards, 4 cards earn you this prize, so the probability is 4 over 500, which is 0.008. Next, what's the probability of winning $47? Out of all 500 cards, 17 earn you this prize, so the probability is 17 over 500, which is 0.034. Finally, what is the probability of winning nothing? Taking away the 22 cards that win you a prize, there are 478 cards left, so the probability of winning nothing is 478 over 500, which is 0.956. Great job! Now that you know how to write probability distributions, you have a better understanding of the games you might take a chance on.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.